Algebra Review Part 3. We'll be solving different types of equations in this, starting with quadratic equations, and we'll look at a couple of different methods. There are several methods for solving quadratic equations, but we're just going to look at a couple of them. The first method is to solve by factoring. So we have x squared plus 2x minus 35. It's quadratic because there's a squared involved. And so if I look at negative 35, I think of all the things you multiply to get 35. 1 and 35, 3 and 5. Because it's negative 35, I know one term has to be positive and one negative. And I'm trying to end up with a positive 2. So that would be a negative 3 and a positive 5. So we'll write x minus 3, x plus 5, keep it equal to 0. Then when it's factored, you'll set each factor equal to 0. X minus 3 equals 0. X plus 5 equals 0. You can actually skip writing that step if you want. Then add 3 and subtract 5. So x is positive 3 or negative 5, and you could plug those numbers back in to check your equation to see if you got it right. However, if the equation won't factor, another method you can use is the quadratic formula, and by this point in your life you should have the quadratic formula memorized, but there it is for you. A is the number in front of the x squared, B is the number in front of the x, C is the constant number. So we'll plug in to the formula x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 10 all over 2 times 1. And then just the part underneath the square root is 44. Now we don't want to leave it like that. We don't really want the decimal. We're going to break down the 44, which is 4 times 11. Can't go any farther with 11. 4 is 2 times 2. So I have a pair of 2's. That means a 2 comes out. The 11 has to stay home. So now we have x equals negative 2 plus or minus 2 square root of 11 all over 2. And then you look at the 3 outside numbers and see if all 3 of them divide by something so you can reduce. It has to be all 3 or you can't reduce it, and never the inside number. So everything divides by 2, and we end up with negative 1 plus or minus, and then we don't have to write the 1 square root of 11 all over 1, which again we don't have to write. Sometimes we come upon equations to the 4th degree that are trinomials, and you can also solve these by factoring. If I look at the back, 27, and I think of all the things you multiply to get 27, and I want to end up with a negative 12. Since it's a positive 27, I know that both my numbers have to either be positive or both negative. If I have a negative 3 and a negative 9, I'll end up with negative 12. So normally you would write x minus 3, x minus 9. But because it's an x to the 4th power, I have to have x squared minus 3, x squared minus 9. Now I can set each term equal to 0. And then add 3. Now I've got x squared, so I need to square root both sides. Remember that when you square root both sides of an equation, you have to put plus minus with the answer. Oops, it should be plus or minus square root of 3. And then add the 9. Square root both sides. And x is plus or minus 3. So I actually have 4 answers because my equation is to the 4th degree. The biggest exponent is 4. That tells me how many solutions I have. Absolute value equations. A couple of steps for those. You want to get the absolute value all by itself, and then you're going to turn your problem into 2 equations. So let me show you what I mean by that. Let's divide by 5. And we have the absolute value of x minus 7 is equal to 13/5. So now that absolute value has been isolated, we'll take the bars away and write the equation twice. First, x minus 7 equals positive 13/5, and then the word or, which is mathematically important. X minus 7 equals negative 13/5. So first equals the positive, then it equals the negative. And then, of course, we're going to add 7. And since I'm dealing with fractions here, I need a common denominator. So 7 is really 35/5. So 13/5 plus 35/5 is 48/5. And then on the other one, I'm adding 7. So I'm adding 35/5. Negative 13 plus 35 is 22/5. The fraction thing should not throw you. If you're still struggling with fractions at this point in your life, you need to get on the internet and practice up on your fractions. Specifically for your book, I gave you a distance, rate, and time problem, and the basic equation for those is D equals RT. However, for your homework problem, you need to rearrange that to T equals D over R. You divide both sides by R. And then you're going to use a chart like they used on page 73, but your homework problem is actually a little bit easier. So I think this should be a 73 probably. But you don't have to use the quadratic formula. Just think about it, kind of use their example, and I know you can do that one. And then you'll also need the Pythagorean theorem for one of your homework problems. A squared plus B squared equals C squared with a right triangle. Remember that C has to be the hypotenuse, and then the A and the B, it doesn't matter.